Okay, hello everyone. Welcome back to our episode 14 of the number series. For today's video, we will be especially doing exercises in dual decimals, which is base 12 actually. Yeah, basically. And let's jump right in. So, question one, we're gonna do the calculation without changing the base. Well, that's just the calculation process and we already covered how do we do the multiplication and addition in the last section. Well, if you forgot, you can go back to check that video instead. So this is the result, and x represent the number 10 in a digit, and this symbol, okay, I forgot its name. Well, the only thing you need to know is to it represents the number 11 of a digit. And part question 2, calculate this. Okay, calculate 3141 in, okay, without changing the bases to 3 decimal places. Well, this is new, so this is the answer. And how we're gonna do this is keep doing those kind of division algorithms. So we first get a number and we push it one digit to the left, and we're gonna find this coefficient, like the maximum number of the maximum multiple of this numbers, and the remainder we take it and we push it to the left by one digit, and we find the maximum multiple and the remainder, and just keep doing this, and you're gonna 0.658, and you continue and you get a decimal expression. Well, you can do this like for infinitely long as you want. And part 3, we're gonna write this number to a decimal, and this thing as a rational number. So we're still going to use our division algorithm here, and we're gonna take all those the digit, and we're gonna find that here 9, and the 9 is going to be keep repeating this part of the digit, and that's why we have like a horizontal line that's above the decimal, that's representing that this part is going to be repeating itself over and over. And how to represent this as a rational number, and we already talked about like how to convert those infinite decimals into some rational expressions. Is that we first push the digit and try to cancel out the infinite part, and we have a whole integer left, and we divide this coefficient here by this number, and don't forget those two numbers at the end, they should be in base 10. Well, all of the answer in the back of the exercises, like for this one, is in base 10, not in base 13. Well, yeah, just keep that in mind. And question 14, write this as a decimal and rational number. Well, this is the answer. Okay. Well, question 5, which would you rather have? Like this many dollar or this many dollar? Well, you're gonna find that this number is slightly greater because of when we are converting it into base 10. Well, I don't know how, like in the real life, how could you have like infinite decimal of the money? Well, this is not really realistic, but I guess they are just going to give you a extra cent in real life. Well, nobody really wants to give you like so many, like the cent, like so many small tiny amount of money. Well, it's kind of stupid. And question 6, show that the last digit of a square is equal to this is, and we're gonna take a look at all of the remainder when dividing those squares by the modulo 12, and that's all we get. 0, 1, 4, and 9 are only possible digits, so that's going to be the only option. So, and we don't even need to check the rest of the square because we know that it's going to be symmetrical to those numbers. Question 7 shows that the last digit of x to the power of n for n equals to 2, 3, blah, 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 is 0 if x equals to 6. Well, we take a 36 out, that's a multiple of 12, so the remainder is going to be 0, okay? That's going to be the last digit. And for part B, it's 4 if x equals to 10. So we're gonna discuss this into two different cases where n equals to 2k or n equals to 2k plus 1, n can't be 1. And we're gonna find that they will keep alternating between 4 and 4, and which means it's always going to be 4 as the last digit of the number, okay? And part C is x if this. So this is what we are trying to find, that all of the x has this magic property, and we're gonna factor this, and we test it out that no matter what is the remainder of modulo 3, that this expression is always going to be multiple of 3. Well, we tested it, like for this part, we're gonna test the multiple of 4, and we find that for those 3 expressions here, that it's going to leading this product to be multiple of 4, and therefore those numbers are valid, and we got all of the numbers here. Question 8. So show that any number whose last digit is this has 3 for a factor. You just need to consider the expression like this in like to the power of 12 by what, right? Like when you use congruence, when you cancel out the things using 3, and you're gonna find that it's always congruent to 0. So no matter what is the digit, and similar to question 9 for those numbers, you just use the same strategy against them. And well, question 10, I guess, and show that any integer whose digits sum to a multiple of 11 is divisible by 11. So this is the number itself, and we take the congruence of modulo 11, and it is actually the sum of the digits. And question 11. So the Duodecimal Society of America have developed so many different forms of unit conversion, and compared to like the traditional base 10 conversion, how are they going to be how are they going to be different? So we're gonna notice that mile, pound, and a pint, they're gonna be slightly slower if we assuming that yards, ounces, and florences is going to be the same as today. Well, it's going to be smaller based on the conversion to the standard conversion according to my research. And question 10, how many days are there in the year? Well, I guess the problem want you to convert this into base 12, but 365 days where it is normal mostly. Well, sometimes every 4 years there's going to be one less day in the month of February. So, okay, that's not my problem. So part B, what other 3 digits number has the property of this? So we're gonna write it in form like this. So we cancel out a few bunch of terms and then we get this. And since we know that each digit have a range, and we can use it to find the first digit, and the first digit equals to 2, and we find that the second digit equals to 6, and the last digit doesn't matter. And similarly, this is the answer for part C. It's going to be equal to the first digit equals to 1, second digit 6, and the third digit 4. And the last digit doesn't matter. And that concludes our section for today. I know this is quite a short chapter, and hope you best luck, okay? And good luck with your study. Goodbye and see you in the next video.